Hi, you're on the Optimistry channel. Today we're going to talk about the possibility of life on other planets. Let's get started. The more we learn about space, the more we are convinced that the Earth is perfect, reliable magnetic field, dense atmosphere with high oxygen content, and a lot of water itself is rare. On the Earth happened a lot of events that made it so comfortable for people. Take, for example, the tilt of the axis. The Earth is tilted at 23 degrees. If the figure was less, as in Jupiter, suitable for agriculture land on our planet would be much less. Because the amount of heat received from the sun would be constant, the equator would turn into hot from the poles, even more frosty deserts, and warm and cold masses of air would be in a static state. That is, no seasons of temperature differences and jumping humidity, and therefore the mountain. There is also atmospheric pressure, forests, sea currents, and many other key things for life that are on the Earth. So one would like to say that the Earth is the most comfortable planet in the cosmos, and it can't be better. But what if it can? Math, physics, and astronomy are ruthless things. If only because these three sciences claim that it is possible for there to be planets in space suitable for life better than Earth. Earlier, Heller and John Armstrong in 2014 even introduced the concept of a superhabitable planet. According to their definition, this planet or satellite characteristics which allow to support a more diverse flora and fauna than on Earth. But how is this possible? To begin with, it is worth looking not so much at the planet as at the star sun. Is a typical yellow dwarf of Class G of the main sequence. We are very grateful to our star for comfortable conditions for life, but still, stars of this type are far from the best for life. This title is worn by stars of Class OK ideal babysitters and caring luminaries for their planets. Usually they, and cooler than the sun, but it is not about temperature to live theoretically possible and at a tiny brown dwarf. The temperature of the star depends only on the radius of its habitable zone. Our sun is a kind of compromise between huge and small, as well as hot and cold, stars, but still, stars of Class G is not the golden mean, because they do not live so long. The sun is already 4 billion years old and is gradually increasing in brightness. Somewhere in another billion years will become a red giant and is guaranteed to destroy life on Earth. It is quite possible that for some time Mars will return to a fully inhabited zone with liquid water, but even in an ideal scenario, its days will also be numbered quite quickly because of the expansion of the sun. We have about 5 or 6 billion years that a star like the sun gives for life. At first glance, that's a lot, but don't forget that it took evolution 3.5 billion years for single-celled bacteria to become human beings, and in a billion years, the sun will kill those human beings. It is here on the arena and enter the arena and class. Okay, stars. They are more calm and live about 40 or even 70 billion years. And therefore the hypothetical life around such stars will have much more time to develop without global cataclysms. Is, by the way, another disadvantage of Class G stars. Our sun is quite unstable, because of which the Earth is plagued by ice ages and global warming. Just a few tens of thousands of years ago, glaciers reached central Germany. It is easy to guess that the diversity of life does not interfere with this. Revolving around a star of Class OK, life will be better insured from the twists of the star, and the fact that it will be able to evolve for tens of billions of years, reaching incredible heights, adds points to the piggy bank of such stars. The fact that they are in the universe much more if stars like our sun are 6% of the total number in the Milky Way. The stars of Class OK is 13%. And therefore the chance of the emergence of life in them is higher. Let's go further and talk about size. It matters in planetary science. If our Earth were 10 times bigger, the pressure that would create a liquid mantle would increase many times over, and most likely the iron in the core would solidify, and the magnetic field would evaporate with it. And instead of auroras, we would have seen the faces of people dying from radiation. This would have been supplemented by constant bombardment by asteroids, which the thick planet would have attracted in packs, and volcanic activity, because more mantle means more attempts to break through to the surface. It is difficult to build accurate models, but in general, scientists agree that life on such an Earth is likely but not too diverse, because there is still gravity, which would make us all 10 times heavier, and many other killer factors. The same can be said about a small Earth here, for the problems do not need to go far for problems in general. Less gravity means less forces, holding the atmosphere with this, and now there are problems. In 2009, NASA calculated the rate of loss of atmospheres, Venus, Mars, and the Earth. The surprise was that the Earth loses it. The fastest, if more precisely daily, goes about 90 tons of substance. Compared to Mars is not particularly correct, because it is smaller and the bulk of the long lost. But the fact is clear. If you magically reduce the Earth, the atmosphere will very quickly blow away and no life to speak of. But still, between the two extremes, there is a golden mean. A planet 1.5 to 2 times heavier than the Earth can boast a couple of advantages. Firstly, twice as strong gravity, which will make the atmosphere denser. This will automatically reduce the amount of solar radiation and lead to a couple of nice side effects. Like erosion and straightening of the relief, the depth of the oceans will decrease. Along with this will increase the diversity of marine fauna, because in shallow waters it is easier to live in shallow water. Tectonic activity will slightly increase, but it is leveled by the huge space for settlement. It is now people on the Kuril Islands have nowhere to go from their volcanoes on a bigger planet, and even with shallow oceans there would be enough land for everyone, and the land suitable for life. After all, a dense atmosphere would increase the temperature on such a planet by 5 degrees, coupled with a high oxygen content. True, it will have to adapt to gravity and trees are unlikely to be as tall, but still, according to scientists, the advantages of the planet are slightly more than the Earth. Outweighing their disadvantages, what else could make a hypothetical exoplanet better than Earth? A much larger number of continents when 300 million years ago on Earth was only one Pangaea. Its center was a weak for green desert, because the farther from the ocean, the drier the climate. The same story was repeated with other supercontinents. And now, the center and Eurasia with the Gobi Desert and Africa with Sahara cannot be called particularly inhabited. Sitespace.com held consultations with astrobiologists, and all to one said that the more small continents the better, they will not be parts far from the ocean. On the planet will be a lot of currents and the diversity of the living world will be beating key. Look at the same isolated Australia with its unique spiders and kangaroos. So the world works that in it, the strongest survives, and the farther life is placed from each other, the more chances for weaker species to survive and evolve into something interesting. In general, as you can see, man is such an ungrateful creature that instead of gratitude, he has devoted hundreds of scientific articles to the imperfections of the Earth, invested billions to find a better planet, and so far has had mixed success. In 2020, Dirk Schultz released a high-profile article with a loud headline about 24 planets that may turn out to be super-habitable, that is, have conditions better than those of Earth. Unfortunately, when examined in detail, it turned out that 23 of them do not meet the expected characteristics. Since then, we have not really advanced in the search for habitable planets. Most often, scientists use math to calculate orbits, masses of planets, and hypothetical atmospheres, but as we have already told you, life is a very fragile thing, and too much can go wrong. The evidence for the existence of a super-Earth is necessary ironclad, and at the moment one of the main candidates is Kepler 442b. This planet fills almost the entire checklist of scientists that we voiced. First of all, it is located in the habitable zone of the star class. Okay, this star is about 40% lighter than the Sun. But Kepler 442b is closer to it. The year on the planet is only 112 days of heat from the star Kepler 442b and still receives about 30% less heat than you and me. But this is corrected by two remarkable details. The size of Kepler 442b is 30% larger in radius and about twice as heavy as the Earth, and therefore all the points about dense atmosphere, shallow oceans, and large space for life are fulfilled. The greenhouse effect from the dense atmosphere, in theory, eliminate the difference in the heat received, which makes Kepler 442b one of the most promising candidates for the presence of life. Although the planet is located 1,206 light-years from Earth, in theory, the power of James Webb should be enough to see it closer. But even if the telescope will find something remarkable with the current development of communication and the speed of spacecraft to check it, we will not be able to soon happy only that the star type, will be life much longer than the Earth. And our descendants have a lot of time in reserve. Also, one of the candidates for the presence of life is the system of the star TRAPPIST-1, in its habitable zone as many as 4 planets, one of which has attracted the attention of scientists. TRAPPIST-1 is a unique world on the physical characteristics of the maximum similar to Earth, the mass radius, gravity, density, even temperature. Exoplanets are very similar to Earth. The problem is that the star of this system is incredibly cold. Its mass is 10 times less than the solar, and therefore the habitable zone to the star is much closer to the year on TRAPPIST-1. E lasts only 6 days, and the proximity to the luminary puts the planet at risk of constant bombardment by radiation. But if by some miracle life has learned to survive them, it can exist for billions of years. TRAPPIST-1 should not be crossed off the list of potentially habitable planets, especially since the world is only 40 light-years from Earth, and the James Webb telescope in this system can definitely frolic. Because the unfortunate truth is that our knowledge of life is not heaven. We have created bombs capable of wiping cities off the face of the Earth, but we cannot create even the simplest single-celled life. This mystery is still unsolved, and therefore any analysis of the planets a priori have no meaning. They are based only on our observations of the Earth, and space is infinite, and life in it may exist in a form of which we do not even suspect. Will scientists of our generation find life in space? Subscribe to the channel. Leave your opinion in the comments. And that's all for now. See you later, friends.